This is Chemistry 2E from OpenStax.org. OpenStax.org is a project of Rice University, very well ranked university for pre-medicine, pre-med, and other disciplines. And this chemistry book can be used for college chemistry, 2 semesters. And so let's dive into it. You can access this book through an app, through downloading a PDF or ordering a print copy. We're going to use the view online option. I like that better because I've experimented with the app and I don't know exactly how to use the note-taking feature with the app, if it even works. But when you use it online, you can log in with your Gmail account, your Facebook account, or create an account here. You can take notes directly from the textbook and it gets stored and you can view it later on different devices. This works on the phone. I've tested on a phone, a computer, and a tablet. So we're going to just view online. And that brings up the introduction page. And we have this handy table of contents here on the side, as well as the chapter outline. A few things to note here is that you can jump straight to the key terms. Gives you all the key terms for the chapter, which is nice. It would be easy to copy and paste this straight into a Quizlet. If you're going to do that, make yourself your electronic flashcards. You've got key equations, which are the mathematical or chemical equations that are talked about in this chapter, such as density being mass divided by volume. This TC, I believe that's temperature Celsius, equals 5/9 times temperature in Fahrenheit minus 32. So that's going from Fahrenheit to Celsius, also known as centigrade. Temperature Fahrenheit equals 9/5 times TC plus 32. That's going to Fahrenheit. TK would be temperature Kelvin. So those are all the formulas that get covered in this chapter. Summary just gives you a brief summary of what each of the sections are about. Like the first section, and we'll go through that. Talking about chemistry in context. And it says talking about the composition, structure, and properties of matter, and how it occupies a central place in the study of practice, science, and technology. They use the scientific method, talk about hypotheses, formulating laws, developing theories, to better understand the natural world, and operating in the macroscopic and microscopic and symbolic domains. And chemists measure, analyze, purify, and synthesize a wide range of substances that are important to our lives. So you know that you're kind of knowing what you're going to be reading, right? You're actually going to learn about the scientific method, be learning about hypotheses and theories, microscopic and macroscopic and symbolic domains. So this gives you some ideas from things I'll be delving into in this section 1.1. So we can click on this here. You could click over here. Either way, this link will take you to section 1.1, chemistry in context. You click on that, brings up your learning objectives. And this knows this is what you're expecting to know by the end of this section. The historical development of chemistry, examples of the importance of chemistry in everyday life, describing the scientific method, differentiating among hypotheses, theories, and laws, and examples of macroscopic, microscopic, and symbolic domains. Now, something else, we'll come back to this, but you can also click at this point and look at what the end of chapter exercises are. And these exercises are broken down into each section, right? We have the section 1.1 chemistry and context, section 1.2 phases and classifications of matter, etc. Now, looking, and it might not be a bad idea to look at the exercises from the end of the chapter even before you look at that section, because that gives you an idea of what sort of things you're expecting to learn, right? Like this one talks about how you could experimentally determine whether outside temperature is higher or lower than zero without using a Celsius or 30 degrees Fahrenheit without using a thermometer. So you'll learn enough in this section to be able to answer that question. Also, they talk about whether these statements are a hypothesis, a law, or a theory. If you remember from looking at the summary, they were talking about the scientific method and understanding the difference between a hypothesis, a law, and a theory. So you'll learn that in that section, and you'll have an idea of how to answer this question. Then we talk about something being in the macroscopic or the microscopic domain or the symbolic domain. So we'll learn about those different domains in section 1.1. And they have two of those types of questions in there. Another microscopic versus macroscopic versus microscopic domain question. So we have about 3 questions about the microscopic versus macroscopic domain. So that should tell you that really, even though they talk a lot about, even though we're going to be talking about history and so forth, the main things that you're going to really need to know from section 1.1 is hypothesis versus law versus theory, and microscopic versus macroscopic domain. Okay, so let's delve into section 1.1, chemistry and context. And again, this is so cool. So hyperlink. So when you're in the exercise, you can go straight back to the text. All right. So talking about throughout history, people have tried to convert matter into more useful forms. Talking about the Stone Age ancestors creating flint tools out of flint, or toys or different things. Eventually getting into pottery, weapons, garments, iron ore. And then one of the first uses of fire is learning how to control fire. One of the first practices of chemistry is learning how to control fire and cook with it, right? Because fire is a chemical reaction. You're turning some type of fuel, wood or something, combining it with oxygen and burning it and giving off carbon dioxide and other things, carbon monoxide and other things. And then it said you learn how to separate components of matter, learning how to make different drugs, learning how to make dyes and different things. We had the alchemists, learn about this in history, Greek philosophers. They were trying to turn lead into gold. They thought that the elements were earth, air, fire, and water. But we know that that's not true. Now we still use the term element, but it means something different. Picture here of an alchemist's lab versus a more modern chemist lab, and so forth. So all of this is interesting. But again, when we're looking at the exercises, the main things we're trying to understand are the scientific method and hypothesis versus law versus theory, and also microscopic versus macroscopic. So let's see here. So from here, the next subsection is talking about chemistry, the central science. Nothing really important here. I mean, it's important, but it's not anything you're going to be tested on or anything, but it's just talking about how chemistry is connected to chemical engineering, environmental science, biochemistry, geochemistry, eventually medicine. That's why pre-med majors and nursing majors have to take chemistry, chemical physics, all sorts of things. Okay, now the scientific method. And now this is the first time we're going to use something called highlights. If you click on this, well, I don't have any highlights yet for this chapter, but we're going to have some. So what we're talking about the scientific method. Chemistry is a science based on observation and experimentation. Okay. Try to answer questions and explain observations in terms of laws and theories. And so here we get into some definitions. So this is important. Some routes involve a hypothesis. Your key terms are often bold in any textbook. And so we get a definition of a hypothesis. A hypothesis is tested by experimentation, calculation, and or comparison. A hypothesis is a tentative explanation of observations that act as a guide for gathering and checking information. So these two sentences we're going to highlight and add a note. And you can use different colors. I'm just going to use yellow and just name the note as hypothesis. And then I'm going to click save. Okay. And now this is kind of covering up my text, so I don't want that. So I'm just going to just click off of it. It goes away, but we still have this highlight here. All right. If you click on the highlight, it brings up this little note here. Click away from it, goes away. We click on my highlights, and it brings up another window that shows that. Now I've done some other highlights for chapter 2, but this is the first highlight in chapter 1. From essential ideas, we have the note hypothesis. Okay. And it's in yellow. You have different types of highlights. You have different colors. And the theme that I'm kind of using is just using yellow for different notes and pink for exercises. But you can use your own color scheme. So some hypotheses are attempts to explain the behavior that is summarized in laws. The laws of science summarize the vast number of experimental observations and describe or predict some facet of the natural world. Okay, if such a hypothesis turns out to be capable of explaining a large body of experimental data, it can reach the status of theory. So we've got hypothesis, law. It says laws of science summarize a vast number of experimental observations and describe or predict. So, right. So we're going to highlight this, and we're going to give this one laws. Okay. Accidentally highlighted a little bit too much there. I didn't want to get over into, so let me fix this here. I'm going to delete this note and be careful to only highlight the part I want to highlight. Okay. And then the next one says, if such a hypothesis turned out to be capable of explaining a large body of experimental data, it can reach the status of a theory. And here we get the definition of theories. Scientific theories are well-substantiated, comprehensive, testable explanations of particular aspects of nature. Theories are accepted because they provide satisfactory explanations, but they can be modified if new data become available. The path of discovery that leads from question to observation to law or hypothesis to theory combined with experimental verification of hypothesis and any necessary modification of a theory is called scientific method. So we got two different definitions here. We got theory, these two sentences. I'm going to do for theory. And then this last one, I'm going to make scientific method. All right. And so they have this little flow chart here. They have observation and curiosity. Then you form a hypothesis and make a prediction. And you perform experiments, make more observations. And if it follows the prediction, if it's not consistent, then you form a new hypothesis. If you do have results consistent, then we go to contribute to body of knowledge. If it doesn't, we go back to does not support the hypothesis. We come back. If it does, then if much additional testing yields consistent observations, the observation becomes law. Much additional testing supports hypothesis. Hypothesis becomes a theory. So, yeah. Observations become laws. Hypothesis becomes theory. All right. So that's the key difference here is we're just talking about the observations, but if we're talking about the hypothesis, the observation would be every time you drop you let something go, and there's nothing to hold it up but air. It keeps falling until it hits the ground, right? And that's the whole what goes up must come down law, but that's not giving but the hypothesis would be grab all bodies as a different bodies with different mass. As they fall, they still fall at the same rate. That's theory and law and theory are very interrelated, but it's observation that becomes law, meaning you're going to see the same thing happen again. And the hypothesis becomes a theory, meaning that you're getting stronger reasons to accept the hypothesis as being true. All right, now it gets into the domains of chemistry. Chemists study and describe the behavior of matter and energy in three different domains: macroscopic, microscopic, and symbolic. These domains provide different ways of describing chemical behavior. Macro is the Greek word for large. The macroscopic domain is familiar to us, includes the food that you eat, the breeze you feel in your face. The macroscopic domain includes everyday and laboratory chemistry, where we observe and measure physical and chemical properties such as density, solubility, and flammability. So all of this falls under the macroscopic domain. Micro comes from the Greek word that means small. The microscopic domain of chemistry is often visited in the imagination. Some aspects of the microscopic domain are visible through standard optical microscopes, for example, meaning biological cells. More sophisticated instruments are capable of imaging even smaller entities such as molecules and atoms. and they have a figure that you can click on and see, where you're seeing the ice, the water, and the water vapor in the clouds. This is a macroscopic version where you can see it. Microscopic, with the naked eye, you can't see the individual molecules, but they're there. And with a sophisticated enough equipment, you could see that. And here, this is symbolic domain. We're getting to that. H2O, H being the symbol for hydrogen. There's two of them. O being the symbol for oxygen. Okay, so that's micro. We're going to highlight all of this and put the microscopic domain. However, most of these subjects in the microscopic domain are too small to be seen even with the most advanced microscopes, can only be pictured in the mind. Other components of the microscopic domain include ions, electrons, protons, neutrons, and chemical bonds, each of which is far too small to see. Okay, the symbolic domain contains the specialized language used to represent the components of the macroscopic and microscopic domain. Chemicals, symbols, what you see in the periodic table, formulas, chemical equations, anything that's written down on paper or today on a computer screen or a phone or tablet, all that is in the symbolic domain. And then this next paragraph explains this figure. A helpful way to understand the three domains is via the essential and ubiquitous substance of water. The water is a liquid at moderate temperatures, will freeze to form a solid at lower temperatures, and boil to form a gas at higher temperatures. Those are macroscopic observations. You see the clouds, the icebergs, and the water. Okay, but the properties of water fall into the microscopic domain, what cannot be observed with the naked eye. Description of water as comprising two hydrogen atoms and one oxygen atom, and the explanation of freezing and boiling in terms of attractions between these molecules is within the microscopic domain. And here you see pictures showing the two hydrogens and the oxygen. The formula H2O, which can describe water as either the macroscopic or microscopic levels, is an example of the symbolic domain. The abbreviations for G, gas, S for solid, and L for liquid are also symbolic. So we see here H2O, hydrogen, two hydrogens, one oxygen, and G, it's a gas. Then here's some more dihydrogen monoxide, also known as H2O or water. S, it's a solid. And then dihydrogen monoxide. L, it's a liquid. Okay. So, now, with that in mind, if you were to look here under your key terms, you would see, we see they have here hypothesis, tentative explanation of observations that acts as a guide for gathering and checking information. Law, statement that summarizes a vast number of experimental observations and describes or predicts some aspect of the natural world. Theory, well-substantiated, comprehensive, testable explanation of a particular aspect of nature, and scientific method, path of discovery that leads from question and observation to law or hypothesis to theory, combined with experimental verification of the hypothesis and the necessary modification of the theory. Okay. And then we talked about microscopic and macroscopic and symbolic. Microscopic domain, realm of things that are much too small to be sensed directly. Macroscopic domain, realm of everyday things that are large enough to sense directly by human sight and touch. And symbolic, see that on here. Symbolic domain, specialized language used to represent components of the macroscopic and microscopic domains, such as symbols, chemical formulas, chemical equations, graphs, drawings, and calculations. So in your end of chapter terms, all of the terms in section 1.1 are in there. But we also, because we took notes as we were going through the chapter, we have all of those same things, right? So we should be at this point able to answer any questions. So if we look at the exercises for, we're just going to look through 1.1. Okay. So this first one, now this requires a little bit of general knowledge that they, well, let me see. Did they mention the freezing point of water in this? Well, if we go down here, when they gave the example, did they mention the? No, they did not mention that. All right, so they didn't tell us what the freezing point of water is, but you should have learned in high school or just from life that water freezes at 0 degrees Celsius, also at 32 degrees Fahrenheit. If you live in the United States, which is the main country that's still using the old English system, you're used to the idea that when it's 32 degrees outside, it's cold. 32 degrees Celsius is not cold, but 32 degrees Fahrenheit is cold. And so that's also the freezing point of water, right? So how could you experimentally determine whether the outside temperature is higher or lower than 0 degrees Celsius? If you look outside, if there's icicles outside, or if there's if there's any water outside that's frozen, or you put some more out and it freezes, then it's below that temperature. If water stays liquid, or if you see frozen water outside melting, it's above that temperature, right? So let's look, and they have the answers for all of the odd questions, but not the evens. So if we look here, the solution, it says place a glass of water outside, it will freeze if the temperature is below 0 degrees Celsius. So yeah, that is that's an answer. Okay, now the other questions actually get into what we actually studied here in the chapter. Identify each of the following statements as being most similar to a hypothesis, law, or theory. Explain your reasonings. So we don't have the answer, but we can look at this. So following barometric pressure precedes the onset of bad weather. So barometric pressure is something that weathermen use to tell if what the weather's going to be, and something that's they've been able to test this for many years now, ever since they invented the barometer. And so, yeah, that would fall if we look at let's look at our highlights, right? Look at our notes. So a hypothesis is a tentative explanation of observations that acts as a guide for gathering and checking information. Well, barometric pressure has been around for so long that people actually use it to try to predict the weather. So I don't think it's going to be a hypothesis. So laws of science summarize a vast number of experimental observations and describe or predict some facet of the natural world. And so, we're predicting something here. this seems like the closest one. Scientific theories are well-established, self-substantiated, comprehensive, testable explanations of a particular aspect of nature. Theories are accepted because they provide satisfactory explanations, but they can be modified if new data is available. You could kind of say theory, but I'm leaning more toward law. We're looking at one of these three. But again, we don't have the answer, but I think A is going to be a law. B, all life has evolved from a common primitive organism to the process of natural selection. Well, that one should be pretty obvious because people always talk about the theory of evolution. And so this sums it up here. And whether you're a creationist or not doesn't matter for the standpoint of understanding and being able to answer these questions. My truck's gas mileage has significantly dropped, probably because it's due for a tune-up. Okay, so this, it could be because it's due for a tune-up. It could be because the tires are not properly inflated. Could be because you're using the wrong kind of gas. So there's different things that could cause your truck's gas mileage to drop. So now, so we don't have a good, strong, just from this one thing, this would be a hypothesis, right? You could test it by giving the tune-up and seeing if your gas mileage goes back up. Okay. Now, number 3, same type of question, but here we have more of, we can check it because it's a odd number. Identify each of the statements as being hypothesis, law, or theory. Explain your reasoning. The pressure of a sample of a gas is directly proportional to the temperature of the gas. Okay. So this would be, it sounds like one of the gas laws, which it sounds like I'm cheating. I already know the answer based on being gas law. But if we look at our definition of a law again versus so some hypotheses are attempts to explain behavior that is summarized in our laws. Laws of science summarize a vast number of experimental observations that and describe or predict some facet of the natural world. So there've been many observations showing doing experiments with pressure and temperature of gas. So I believe that's a law. Matter consists of tiny particles that can combine in specific ratios to form substances with specific properties. Okay. I believe that's going to be more of a theory, right? Because let's look. It's always good to go back and look at your definitions from your notes. Scientific theories are well substantiated, comprehensive, and testable explanations of a particular aspect of nature. Theories are accepted because they provide satisfactory explanations, but they can be modified if new data becomes available. So we're talking about explanation of what happens. We can't see the tiny particles, but we can test it, and now we're getting with a scanning with certain microscopes you can see the tiny particles, but before that but they were able to come up with these ideas before they had those great microscopes. So this is more of a theory. At a higher temperature, solids such as salt or sugar will dissolve better in water. I believe that will be a hypothesis. And I don't know if it's true for all solids. It might be. So if we're saying law, theory, hypothesis, I think that's going to be it. You click on, see the answers to number 3, law, theory, hypothesis. Okay, so that was correct. So let's go back to the let's go back to our exercises. All right. For the sake of time, I'm going to just go over the ones that we can check. All right, we're going to talk about macroscopic, microscopic, and symbolic. Okay. A certain molecule contains one H atom and one Cl atom. So we're only dealing with the symbols here, right? They didn't talk anything about the weight or the volume or anything. So that would be symbolic. Copper wire has a density of about 8 grams per centimeter squared. I believe that would be macroscopic. Macroscopic. A bottle containing 15 grams of nickel powder. Definitely macroscopic. A sulfur molecule is composed of 8 sulfur atoms. And this would be microscopic, right? They didn't use any of the symbols. They spell everything out. And on top of it, we're talking about, you could draw a picture of that. And so I believe that this would be symbolic, macro, micro. Let's see. Symbolic. They said symbolic, comma, microscopic. Okay. B, macroscopic. C, symbolic, macroscopic. D, microscopic. Okay, so let's go back. I didn't realize that the way they did this, you could have two answers to the same thing. But, okay. So they gave you the symbols, H and Cl. But we're talking about the molecular level. And so that would be microscopic. Okay. All right. Here. Was this just macroscopic? Right, because we're not using the symbol for copper wire. We're using the words copper wire. We have the grams and centimeter squared, but we're using the word copper wire. Here, we're using the symbol for nickel. So this would be symbolic, and grams is macroscopic. And then this is just microscopic. Okay. All right. Makes sense. All right. Last question. Question number 7. The amount of heat required to melt 2 pounds of ice is twice the amount of heat required to melt 1 pound of ice. Is this observation macroscopic or microscopic of the chemical behavior? Explain your answer. So we're talking about temperature. This is something that you can observe, in the real world. You don't need a microscope or anything to observe this. You have 2 blocks of ice, 2 pounds of ice, and how much heat. So this would be macroscopic. So let's see the answer, number 7, and macroscopic. Right. Determined from macroscopic properties. All right. So, that is everything from section 1.1. If you do this for every section and then come back and review your notes right? And then go over all the exercises. You should be able to get a good grade on a test based on this book.